Well, there was a short gap between these two lectures, which I hope you've enjoyed to the full. And now we come to a very different topic from last night. I have spent some little time in the last few minutes, perhaps rudely, looking at people's labels and trying to read who they are. And I find that sometimes it's rather difficult to do that, particularly if, as in this case, they're the wrong way around. Now, if anybody can invent a method whereby a label automatically gets the right way around, there's big money in there. You just try. But sometimes you can't see them because they're not in focus. At least when you get to my age, you have to have glasses to see them. And that is an analogy for what I'm going to do today. For whereas yesterday we tried to look at a few general points about the way that you can look at the history of science or religion, and if I may remind you about the three major points that we made. One was that there is a possibility of choice. There are various kinds of interpretation you can place on things, but when all is said and done, it is still possible to come to a reliable historical analysis, but there is that possibility of choice, and we do have to avoid making simplistic generalizations. Secondly, there was the prevalence of myth, all kinds of myth, from Newton's apple to what we call the conflict thesis. And we tried to see how the latter actually came into existence. But undermining and underlying all of those is a third thing, which was the priority of data. You have to have your data as you do in science. Not from the lab, but from documents and from primary and secondary sources, and you have to have the evidence. It's a different kind of evidence, but it's still evidence. And when all that is done, it is possible to not only to explode a lot of these myths, but also to get much further forward in our understanding of how science and religion interacted. Now that was a long focus look. Now I want to tighten the picture very much more and to look simply at one example. And in doing so, looking at it close up, I am conscious of the fact that most of you are not astronomers. Never fear, this will be relatively painless, but I hope that you will see that in the story I'm about to unfold, there are some very important lessons for today and indeed for tomorrow. This isn't just a few anecdotes about what happened hundreds of years ago. And I've entitled this talk, Copernicus and the Bible, and asking, are there any lessons from that story that we can learn today? Now, I've chosen this for two reasons. Well, one is that I know a bit about it. That's not the main reason. One is that the Copernican revolution took place so long ago that we can be much more detached about it, much more objective than we can say about evolution, which is still a subject of hot debate in certain quarters. And the other thing is that pretty much everybody now is agreed on the facts. And if there are any flat earthers here, or any people who believe that we really are at the centre of the universe, then you are in for some big surprises, because it ain't like the way it is. But we are all agreed. So it's easy to be objective and look at this in a much more laid-back way. That's why I've chosen it. So here we go. And I assume you know nothing about it. If you do, forgive me for being simplistic. Here is Nicholas Copernicus, a man who was born in Torun, which was either in Germany or Poland, depending on where the boundary was at that time. They both claim him, 1473 to 1543. He lived in Poland for nearly all his life. He travelled about, and he studied medicine, and eventually theology, and he wasn't ordained, but he became a canon of Frauenburg, which is a town on the Baltic coast, beautiful place, very isolated, from Book it's called now, And this is where Copernicus did his great work. A town where the cathedral closed and these great buildings are still enclosed by this wonderful brick wall. And Copernicus studied astronomy as they did in those days. This is a model dating back to the year he died, 1543. It's called an arbitrary sphere, and it shows how people could think in terms of the cosmos with the Earth. That's a big lump in the middle, and the diagonal line is the eccentric, in which is the plane in which eclipses took place, and the planets went around that. But Copernicus, in fact, overthrew that. And he came to a view that the Earth was not at the centre of the universe, but the Sun was. And he knew that this was going to be regarded as heresy, because all the Christian church at that time, and everybody, knew that the Earth was, of course, at the centre of everything, and everything went round us. That's what the universe was for. We were here to enjoy it, and it was here to serve us. And when eventually he published his book, it was literally on his deathbed, where the church could no longer get it. And here is a copy of the title page of one of the books that still exists, Nicholas Copernicus of Turin, and the book De Revolutionibus Orbis, concerning the revolutions of the heavenly bodies. That's the short title. And this book was destined to change human history. Now before it, there was a system which dated back to the 2nd century AD, when a man called Claudius Ptolemy, proposed a detailed map of the universe like this. Sorry, the wrong way around. That's Copernicus's picture. I'm sorry, I've got it the wrong way around. And here is the Sun at the centre, with the orbits in circular form around it. Apologies. This was the one I meant to show. This is the Ptolemaic one, the one before it, where the Earth was at the centre, the Moon, Mercury, Venus, Sun, Mars, Jupiter, Saturn, all orbited round the Earth. Now Ptolemy put this forward in AD 20, and it was Copernicus's great achievement to change it over, simply to change the coordinates, putting the centre of the universe with the Sun, and everything goes round the Sun. But there were problems with Ptolemy which Copernicus had to address. This Ptolemaic system, for example, couldn't explain a very simple fact of planetary astronomy, a thing called a loop of retrogression. If you're on Earth and you watch a planet going across the sky and mark its position at the same time each night, it gradually moves along the sky, in this case from west to east, and then suddenly it sort of changes its mind, goes back a bit, and then goes on. Now, how on earth could that be? Well, Ptolemy had a whole series of devices to try and explain it, and this is one of them. This is what is called an eccentric, where the planet P moves around in a little orbit, and the Earth is at the centre, but as the planet whirls round, you can see that from time to time, when it gets to the bottom of that circle, namely when it gets to here, it's going in the opposite direction to the way it's going that way. And if it's carrying on there, you will see a loop of retrogression. And that did indeed explain, and quantitatively moreover, much of the planetary anomaly that worried Copernicus. But Ptolemy got around it in that way. He also had another device called an equant, which explained various quantitative features of planetary movement and of the sun's movement, apparently around the sun. In fact, he said, in fact, the movement of the sun is going around the Earth. There's the sun, or a planet for that matter, going around the Earth at uniform circular motion, but it is uniform as viewed from a point here called the equivalent, so that from the centre or from the Earth it's not going round in a regular fashion. Again, it was a mathematical device that worked quite well. Here's another one, and this, in this one, the Earth is moved eccentrically from the centre to here, so that although the centre of the orbit is there, the Earth is not quite at the centre of the orbit, nevertheless the planet still goes around the Earth. Well, these things, and I can't detain you with the technicalities, did give a pretty convincing picture. They fitted the facts, and they enabled predictions to be made of all sorts of things, and they were very satisfactory. So why did Copernicus come along and mess it all up? Well, this brings me to the end of my introduction. That's a difficult bit, that's a technical bit. Why did Copernicus change all this? Which brings us to ask at least 4 questions. And the first question I'm going to ask concerns something very much more general, the origins of scientific theories. Because the Copernican theory was a scientific theory. How do scientific theories originate? How did this one originate? It was interesting to look at the Copernican case. Well, first of all, by experiment. If you want to produce a scientific hypothesis, you conduct hundreds, probably thousands of experiments. Often nowadays on a computer, but still experiments. Now, in the case of observational astronomy in those days, there was no way experiments could take place. You could not manipulate the universe. You could manipulate your own environment, but you couldn't manipulate the universe. So experiment was not one reason why Copernicus actually changed his view. We can rule that out. There weren't any. What about observation? Now we're coming warmer, because that is exactly what astronomers did, and what astronomers, of course, still in large measure do. They observe. Copernicus had no telescope. He had that was invented after he died. He had no sophisticated electronic equipment, no electronic equipment of any kind, sophisticated or otherwise. Copernicus simply had a series of instruments where you could measure an angle and not greater than an accuracy of 10 minutes. It was a very small angle, but it was not. It was in fact not capable of giving any better results than that. And Copernicus did do some observations. And here is the tower in the shadow of the cathedral, which is behind it, where Copernicus did his operations. And it's still there, and presumably didn't have that roof in those days. They might have done it. He could have worked through windows. And Copernicus observed. Now, he was not a great observer. This is where people often get it wrong. They think Copernicus changed the world because the power and the impact of observations was so great that the old theory collapsed under their weight. That wasn't true at all. Copernicus was not a great observer. In fact, he only made 27 astronomical observations that he used in his book. See, you couldn't say it was based on a multiplicity of observations. Nice to think that it was. And in fact, it wasn't observation that led Copernicus to his theory. Or was it then? There's only one other possible explanation. He had a hunch. He had a hunch for all sorts of reasons. He did not like the Ptolemaic system, partly because it was too complicated, partly because it was inaccurate in a few minor respects, which is where his observations came in. But I think in Copernicus's case, there is now no doubt that he was deeply influenced by his education, as we all are, and particularly by the wave of Neoplatonism that was sweeping through Italy, where he had spent some of his formative years. And there in Italy he came across this Neoplatonic reverence for the universe, which particularly reverenced the sun. And Copernicus was aware of some of the ancient Greeks, like Heraclides, who had guessed with even less evidence than he had that the sun was the central feature of the universe. And Copernicus, it said, resurrected those ideas. They were dead for 2,000 years, nearly. But Copernicus, wittingly, I think, he knew about them, resurrected them, and they seemed to him to be aesthetically and in other ways better. Now this will probably shock you profoundly, because this great theory, on which I believe all of us believe, in which all of us believe, emerged in 1543 as a result, very largely, of a hunch, or a series of hunches. Do you know it was not proved, experimentally or observationally, until 1838, when F.W. Bessel observed for the first time a thing called stellar parallax, which did show, in fact, that the Earth was not at the centre of the universe. That's nearly 300 years. And that, during that time, Newtonianism, before that Kepler and others, transformed our understanding of the cosmos on the basis of what Copernicus had said. Now, you may be interested to know that the initial reactions to Copernicus were very muted, and it's been said that there probably weren't more than about 10 people who believed in the theory by the end of the century. But the book was printed, it was circulated, and thanks to the results, the research of Owen Gingerich over in Boston, he has shown where the copies went and who read them and what they were. And he looked at all the surviving ones, 700. So, the origins of scientific theories are quite complicated, and in the case of Copernicus, it was this last one that we as scientists are not particularly proud of. Came to this view on intuitive grounds. And this, I do suspect, is very true of a lot of theories that we have around today. Theories that we hold to passionately, but often with a strong element of intuition in them. There's nothing wrong with that, so long as we recognize that that's the way it is. I was discussing over breakfast with some of you the evolutionary situation, and we agreed that the theory of evolution is at best a hypothesis. It's the best we've got, but it's only a hypothesis, macroevolution. And the way it was come to was a way that did involve hunches on Darwin's part, as well as in his case, a lot of observation. So let's remember that scientific theories, and Copernicanism, not least of all, was a result partly of a hunch. Now, my second point. And this is that we must take into account the difference between a world picture and a world view. A world picture is a mechanical picture, almost a mechanical model, of the way things physically are. And when Copernicus came up with his theory, with the sun at the centre, and the Earth going in a circle around it, and the other planets as well, of course, that was a world picture. Now that world picture has been modified. It's been modified by Kepler, who showed that the movement was not circular but elliptical, and it's been modified by Newton, who of course attributed all, or almost all, to gravity. And this picture, this world picture of Copernicus, though it's been slightly changed, is still around today. We still don't believe the Earth is the centre of the universe. Now, whether the sun is the centre of the universe or just of the solar system is another matter. But as far as the solar system is concerned, we are all, I think, convinced Copernicus. But that is quite unproblematic to people who have a strong religious faith, because what they have is not a world picture, but a world view. Here is a classic picture of two astronomers, one of the new kind, one on the left, the one of the old, who relies on documents and data and observations of the past, talking about the way the planets move. And they have two world pictures between them. One of Ptolemy, one of Copernicus. The world view that the Earth is at the center of God's universe, that the Earth is a special place, has in a sense nothing to do with astronomy. It may be true, it may be not, but it has nothing to do with astronomy. And it is that distinction that was to come out during the years of great conflict, to which we shall refer in a moment. So, there's Copernicus then. He's come up with this theory. He's come with it for all sorts of reasons that we would regard as very funny today. We happen to believe he was essentially right over the world picture, with a few details changed. But the notion that he had displaced man from the center of the universe relates to a worldview, which concerns values and morals and things of a theological kind. And on that, Copernicus was silent. But there's a third thing to which we come. A third very important factor in understanding how Copernicus got where he did. That was about the influence of the organized church. Now here is a very strange anomaly. It is often said that the origins of modern science, Western science, came from the Protestant Reformation and that they were in fact promoted in the British Isles, or in England at least, by the Puritans in the 17th century. And there's much truth in that. But going back to yesterday and recognizing that the complexity of things means that we can't make two simple generalizations. The idea that science could not flourish, therefore, in a Roman Catholic situation is one that is oversimple. And here, at the very beginning of it all, Copernicus was a Roman Catholic in intensely Roman Catholic Poland. Indeed, Copernicus himself was a son of the cathedral. There's Fraunburg Cathedral, as it is today. Not very different from what it was then. Very beautiful, rather gaunt building with places where Copernicus can be identified. He served there for many years as a canon. And the Roman Catholic Church taught, as the medieval church always had done, that the earth was specially favored by God, it was the center of the universe, and that everything else was for its sake. So here was the organized church represented by Fraunburg Cathedral, and yet here was Copernicus undermining this tremendous tenet of the church's teaching. How could he do it? Well, the fact that he didn't publish till he was almost dying is a significant one. It shows he was aware of the opposition, but nevertheless he did publish. And he did have the courage to put into print what he said, what he believed. And in his book, De Revolutionibus, he explained with, I think, tongue-in-cheek, you didn't actually have to take this as literally true, but it might be a good model of what things were really like. And he dedicated some of this to the Pope. But he was nevertheless a Catholic, and the church was clearly exerting its pressure on him. There must have been counter-pressures, more than just the man's conscience, surely. It's possible a man's conscience on its own can cause him to break through a crust of tradition that's 2,000 years thick, nearly, 1400s. But no, because we now know that Copernicus was in a most interesting situation. There was a preface written to his book by a man called Osiander. Do you know who Osiander was? He was a Lutheran priest. A Lutheran priest writing a preface to a book by a Catholic, in which he commended the book. That is in itself interesting. But so also are some of the friends with whom Copernicus was associated. One of them was this man, a man called Tiedemann Gies, Giese. He was a bishop of Kulm, later Ermland, and he was a close friend of Copernicus. He was also an extremely liberal-minded man, and he knew and had friends in people with people in the new and explodingly growing Lutheran church across the border in Germany. More. Here is Erasmus, a man who once spent some of his time in Cambridge at Queen's College. Erasmus, whose influence in the church at that time was coming to its maximum. He died in 1536, just 7 years before Copernicus did. And Erasmus, though within the Catholic Church, had an extremely liberal view. It was he who encouraged Osiander to write that preface. We know a lot about Giese and what he was doing, how he was operating, and one of the people he encountered was a man called Rheticus, who we shall meet again in a moment, and Rheticus actually became Copernicus's one and only research student. And Rheticus was a Lutheran. So, in the heart of this Copernican revolution, there was this strong Lutheran emphasis. But it wasn't Lutheran so much as Erasmian. It was an emphasis which said, look, we have got to move with the times in the Catholic Church. We have got to be open to new truth. Look what's happened to Luther, how he has. We must respond in a similar way. And when we tend to think of Poland as an eminently Catholic country, what we forget, or rather forget, is that the Poland of Copernicus was the Poland before the Counter-Reformation. The Counter-Reformation took place within a few years of Copernicus' death, and then the Church brought all its heavy battalions to bear and clamped down on dissent, clamped down on liberalism, and became the persecuting Church of the Inquisition. But that was after Copernicus had died, and we must not apply to the pre-Counter-Reformation Church the properties of the Church after about 1550. So we have this extraordinary situation that Copernicus, a Catholic with strong liberal traditions, was able to shape the foundations of our thought and society by a theory which was a hunch, but which could be held by a devout son of the Church. But even that isn't sufficient explanation. And I couldn't give you a better explanation had I been speaking before the 1970s. But since then, we now know a whole lot more. And I come to my last point, on which I will spend a little more time. We're in relation to the Copernican revolution, and that concerns the relevance of the Bible. For the biblical text, which had electrified Luther and had enabled him to see the grace of God comes not by works but by faith, the biblical text was also disseminating in the Catholic Church before the Counter-Reformation, which is precisely why the Counter-Reformation happened. And I want to tell you about some work done by this man, Roger Hoykias. He was a professor at the Free University of Amsterdam, and then at Utrecht, very distinguished historian of science, a polymath if ever there was one. It was my privilege to know him in the years before he died. He was a great scholar, honoured by the Catholic Church and by the Russian Revolutionary Council at one and the same time. And he made a discovery that I hope one day, well, I know I won't, but it would be lovely if I could make something of that magnitude. There had been rumours circulating for several hundred years that Copernicus's student, Rheticus, had written a book about how Copernicus got round the biblical texts which spoke about the sun standing still. You know, there's this famous story of how the Israelites were mopping up their enemies, they needed more time, and the sun was setting, and Joshua was told, according to the biblical account, to say to the sun, hey, stop moving around there, just sun, stand thou still. And you're told it did stay still, and they had enough and more time to mop up their enemies. Now, the point is not whether this is what the meaning of this picture is, but you don't say, stand thou still, if it's still already. Therefore, the people who read the Bible said, well, this means that the sun is moving. If the sun is moving, where does that put us? There were many cases which said that, text from the Psalms, thou hast made the earth, that it shall not be moved. Copernicus is moving it. That's what he's playing at. And all these texts, and lots of others, were brought to bear on Copernicus. The point is that these reflected not the world picture of the Bible. The world picture was that of ordinary men and women at times. The sun didn't move, but a world view. But Rheticus apparently had dealt with this problem. Somewhere along the line, he had written this book about how Copernicus coped with the church. But the book had disappeared. Nobody had seen it for a couple of hundred years. And it was commonly regarded as a myth. Then one day, Hoykias was in the library of Nijmegen in the Netherlands, and he was looking through a collection of bound tracts. You know how they used to get these tracts, about 20 pages or thereabouts, and bind them into a big book. And he was looking through a group of 18th century booklets, all bound together on one set of covers. And to his astonishment, he found a book that clearly was not 18th century, but much, much earlier. And to his astonishment, he realized that he had discovered the missing copy of Rheticus's book. Here was the book that Copernicus's own one and only research student had written about the universe and the Bible. Well, Hoykias was rightly sceptical. This could be a forgery, this could be a joke, or whatever. To cut out a very long story short, I haven't got time to go into the details. He went through this book, and it was clearly evident to him, and then to all the other scholars who were able to see it, that this was the real thing, the genuine article. And here, in print, coming to light for the first time for centuries in, I think, 1973, was the missing book. And it told us all about Copernicus and the Bible. Well, I've got a copy. I meant to bring it here, but I see I've forgotten to, and I do apologise for that. It was published by the Dutch Academy of Sciences, Royal Dutch Academy of Sciences, and we're there in Promoter, and with Hoykias' translation, because it was written in Latin, and copiously noted. And one of the things that comes out of this is the fact that Rheticus was arguing that when you read the Bible, you have to distinguish between literal statements and allegorical ones. He doesn't use the word between worldview and world picture, but that is what he means. Rheticus quotes some of the ancient fathers who show clearly that they did not regard a literal interpretation of many biblical texts as at all sensible. I won't give you examples, but there are many of them. And he quoted Augustine, particularly, whose doctrine of accommodation was at the root of what Rheticus was thinking. And he said this, that when God gave the sacred text, the Holy Spirit accommodated himself to the understandings of ordinary people, which meant that ordinary people could go ahead and actually understand what was meant. If Genesis 1 had been written in terms of big bangs and quanta and all the multiplicity of things in one science, who on earth would have understood it? If the Bible had been written in terms of the Copernican universe, who would have believed it? So obviously the earth is still. We're not shaking. It's common sense. And so Augustine, as far back as that, said, the Holy Spirit accommodated it. And here is just one page of that book, where it's in Latin, I'm afraid, but it speaks about the most noble mathematician, that is God, who has given us the scriptures, and there's more and more on this. He quotes Psalm 103 and David, who talks about the firmament and the stability of the earth. He quotes many other passages of scripture, particularly the Psalms, Zechariah, and so on, all of which seem to suggest a stationary earth, but which, in the light of the principle of accommodation, of evergreen, do not necessarily mean that at all. Now, the interesting thing about Rheticus is that what he went on to show, to say, is that this was the view of Copernicus. He keeps referring to my master, and my master doth think this, my master does say that, my master. So here we have, for the first time, certainly in living memory, for a long time before that, actual data, hard data, hard as you want, to tell us how Copernicus actually thought. Now, precisely the same thing, the same view was held by Calvin. John Calvin wrote in a similar way, by Rheticus himself, and almost certainly by Luther. There's some myths about Luther which have been exploded recently, but it is likely that most of the Protestant fathers held these views. It is therefore an eccentricity of the last century that we should go back to a primitive medieval view and thinking that the text of Genesis, for example, had to be taken as a literal scientific statement. And all these people believed in the truth of Scripture. The truth of Scripture wasn't an issue. It was what kind of truth was it? Was it scientific truth? Was it poetic truth? Was it theological truth? But it was still truth. They weren't undermining Scripture. There are many looking at it. And if any lesson is needed on this side of the Atlantic, and even more on the other side today, this is the lesson surely. And Copernicus teaches us superbly. On the basis of hunches, he gets to the right answer. And he does not allow the literalistic interpretation of the book of Genesis, and of the Psalms, and of many other parts of the Bible, to stop him. He still is a passionate believer. No doubt about that. But he does not allow this to happen. Would that have been the happy ending to the story? I could have sat down, you would be more relieved. But it's not almost a happy ending. It's almost the ending, but it's not a happy one. For after Copernicus came Galileo. Galileo, who was the first man ever to turn a telescope to the sky in the year 1610. He got these two lenses and he could see an astonishing range of things that nobody had ever thought of before. He showed, for example, the existence of sunspots. The sun has spots on its face. The sun, this great deity, this great centre of the universe which men had worshipped for millennia. Yeah, the sun had flares and prominences, and it had spots which went round slowly. And Galileo saw them for the first time ever. Incredible. That certainly was a blow to the old Ptolemaic view of the perfect sun going round the earth. He saw Venus had phases. He saw Venus had moons. And these moons, 4 moons, which he tracked around Venus, suggest here's a mini solar system in space, totally incompatible with all the other data that Ptolemy would have produced. And Galileo proceeded to follow this up, and he became a convert to Copernicanism. Galileo, who was an Italian, as you know, and about whom, again, there's a lot of modern mythology, some great fun. Galileo's Daughter, excellent book, but it's fiction. But Galileo wasn't fiction, Galileo was fact, and Galileo published a number of books. He published particularly a book called Concerning Two World Systems. This was a book in which 2 philosophers, well 3 really, 3 philosophers argue about the system of Copernicus or the system of Ptolemy. This was in the 17th century, 70 years after Copernicus' death, and they're still arguing. There's the wise man, and there's the fool, and there's an observer. The fool is called Simplicio, and Simplicio, of course, believes in the old system. The wise man believes in the new system. And it's a bit of a knockabout debate. And he goes on, unfortunately, Galileo, gifted man in many ways, was not over-gifted with tact. And into the mouth of Simplicio, he puts direct quotations from His Holiness the Pope. And the Pope, he recognized that he was being lampooned mercilessly, and he didn't like it. Galileo's Concerning Two World Systems was not only a knockabout comedy, it was also nearly the death warrant for its author. To cut a long story short, Galileo was summoned on trial for this creation of the Counter-Reformation, the Inquisition. Sorry, I got this upside down, I beg your pardon. And there is a 19th century imaginative painting of Galileo standing up boldly before the chairman of the Inquisition, who is castigating him. He is on trial. It has been said he was on trial for his life, but that was not actually the case. He was already getting on in age, he was 70 or something, and he was, in the end, condemned for heresy. And he was forced to kneel before the table, and with a white penitential shirt on his shoulders, say, I abjure the heresy of the movement of the earth. He didn't, but that's what he had to say. The result, this man was condemned to life imprisonment. At home, admittedly, the man in his 70s was hardly thrown to the common jail. His eyesight was failing, And Galileo ended his days in a very sad way. The poet Milton visited him when he was towards the end of his life. Galileo paid almost the supreme price for opposing the church. But he, even more than Copernicus, was a devout Catholic. So how could this be? Well, Galileo wrote a lot of things. And one of them, in 1615, was a letter to one of his patrons. In those days, scientists had patrons. I don't think we'd like it very much today, but well, we do have patrons today, but they're usually multinationals or large benefactors, but individual patrons in those days. And one of his patrons, who sort of kept him going with his astronomical work, his work on falling bodies, all that sort of thing, he did a lot of work on that too, was a lady called the Grand Duchess Christina. And in the year 1615, he wrote a long letter to the Grand Duchess Christina, all about the same thing that Rheticus had written about. Namely, about how you could deal with modern cosmology, as in those days, and biblical text. It's a long, long document. It's been known a long time, unlike the Rheticus one. It wasn't lost. It's been translated, reprinted. It's freely available today. My memory certainly writes about 15 tightly typed pages of text. Anyway, in this letter to the Grand Duchess Christina, Galileo rehearses the same sort of argument that I've been talking about today. And he goes back to that document, which you can see there being pointed to indignantly by the furious Inquisitor, which is the Bible. How, Galileo, can you possibly deny that this holy book says that? Galileo made one memorable comment of many in this letter to the Grand Duchess. He said, I am concerned to say this, that when the Holy Ghost gave us the scriptures, it was not to tell us how the heavens go, but how to go to heaven. A statement of great profundity, tremendous importance, as relevant, I suggest, today as it was then. And to those of us who hold with deep affection and respect for the scriptures as the Word of God, is a great clarion call for us not to inhibit us in our science, but to proceed with it, because the scriptures also exhort us to study and to rejoice in the created world all around us, the world of stars, the world of beasts. And if you deny that, I do suggest you read the Psalms. The Church of England, which used to sing the Psalms regularly, has now got into the habit of not singing them regularly, or in some cases not at all. And it's lost out, I believe, because the Psalms have a great deal to teach us about the universe. And it has been, I think it was C.S. Lewis who said, we have ceased to value the created world when we cease to sing the Psalms. Now, I'm not advocating any particular form of ecclesiastical worship. I'm merely reporting what I believe to be a fact. And if you deny it, read, as I say, the Psalms. If you deny it, read the book of Job. Job's all about suffering and about this poor chap who gets into no end of a mess, although it comes all right in the end. And by the time you got to about 3/4 of the way through, most people have given up. But if you persist and read the last 4 chapters of the book of Job, they are all about the created world, in which God revels in the majesty and wonder of his creation of animate life and inanimate life. Incredible descriptions there. Read them and exalt in them. They and many others are parts of the Bible which show us that we must rejoice in creation and we must study it. And we study it with reverence. And as this last sad picture shows us, we must study it bearing in mind that there will be those who, for all sorts of reasons, wish to tie us down to a narrow interpretation of it, or alternatively, to write the whole thing off as a load of rubbish. Each is utterly reprehensible, I believe. And I think the story of Copernicus and his incredible achievement, the Copernican revolution, is something that has a message for us today as well as it did in the 16th century. Thank you very much. Sorry, I think I got the question right. Where did Copernicus come into contact with Aristarchus?
Yes.
Yeah. Well, that's easily answered. In those days, theological students always studied the classics as well as other things as well. And the Greek classics included, of course, Plato and Aristotle, who made references to Aristarchus. Whether he actually encountered Aristarchus as a document in itself, I think unlikely. Aristarchus' work is reported in later Greek writings, which Copernicus would certainly have met in Italy, and later on in Krakow, where he also studied, where there was again a great centre of classical learning. Not just Aristarchus, but Heraclides and many of the other people who got near to a Copernican view but didn't quite make it. Isn't it? Aristarchus is very interesting. He's a good example of what historians call a stillborn hypothesis. He got all the details there, but for some reason or other, he got nowhere. There are many cases of stillborn hypotheses in chemistry. In science. One in chemistry is the famous hypothesis of Avogadro, which would have solved the problem of atomic weights in 1811 when it was proposed. But for 50 years, it was ignored. And chemistry in the first half of the 19th century, organic chemistry, which is my subject, got into no end of a mess because it couldn't know what atomic weights were. And the answer was already there, Avogadro's hypothesis. It was still born, and it was later resuscitated in the 1860s. But that's just another example. And I think the reason why these hypotheses are still born is not that they're not seen to be true or false, but the social conditions and the cultural conditions aren't right for their maturing. If you sow a seed, it's got to go into warm soil. And the same is true of scientific and other theories and hypotheses. As on the opposite side, some theories, some views, explode like wildfire. And that's what happened with Luther's Reformation, for example. Again, the social conditions were just right. So that comes back to what I was saying yesterday about complexity. Don't let's think we've got one answer. All these factors are relevant and we need to take them into account.
Thank you. More questions? Yes?
I have a couple of questions. They are connected, so that's why I put them together. One of them is, we have encountered since yesterday a lot of scientists who had a strong faith in Christianity, starting from these two people,
Sure.
Devout Catholics today, and then Newton, Robert Boyle, Michael Faraday. Now, is it not possible that, well, they were all, particularly the people who were at, like Copernicus, who was a canon, or Galileo, who had read the scriptures very carefully and understood them, that they were also highly educated. And a lot of science, in order to do good science, you need a certain amount of education. And people belonging to a certain class could only contribute to it, like the lower class, which were not educated, could not. And
can we look at that one first?
Okay.
And then come to your second one. This was a question about education. Were some of these great scientists who happened to be Christians in the UK and in Europe, weren't they great scientists not because they were Christians, but just because they were educated? I think my reply to that would be quite complicated in that there are lots of people who were educated, who didn't become scientists, and who didn't hold to a Christian view of life. It's interesting that if you do a sort of sociological analysis over the last 100 years or so, you find that the proportion of Christians among scientists is much greater than it is among other professions. And that is a very interesting fact. I happen to know more Christians who are scientists than who are anything else, and that's my trade. Okay, so you'd expect that to be the case. But I don't think it's totally untypical. So education obviously helped, but it's not a sufficient explanation. And a lot of people who were educated and didn't make great scientific discoveries, people whose names you've never heard of, nevertheless had a profusion of writing about science and the faith. I've recently done some research on hydrotheology. Have you heard of hydrotheology? Theology of water? I suspect not. Well, it was once regarded as a bit of a joke by historians of science, because in the 18th century, natural theology, that is, arguing from nature to nature's God, was very much in vogue, had reached its peak with William Paley about 1800. But there are lots of people who wrote before. There's one chap who wrote a book about insect theology, another about the theology of animals. John Ray was one, and William Deere was another. And as a footnote in one of the history of science textbooks was somebody actually wrote about the theology of water. Ho ho! How can you do possibly that? The fact that water is an utterly unique liquid, it has about 15 properties which are not shared by any other liquid, and there is so much of it, is in itself a pretty astonishing thing. Without water we would not have life, that is for sure. Anyway, I was in college and I was asked if I'd look at this. So I found this book with great difficulty, called Hydrotheology by a German in the early years of the 18th century. And it's that thick. It's not about the sorts of property of water that we know, which are due to hydrogen bonds, but due to its, that are about its large-scale operations in history, in changing climates, in giving transport possibilities, and all that sort of thing. And the guy is arguing that this is showing the greatness of the God who designed it. Now my point is, in answer to your question, here is somebody who was obviously, he was a professor of, I don't know what, in the university in Germany. I say I don't know what because he seemed to write books about everything. There are people that do. Anyway, he was one of them. And this book showed, in a large scale, how one man, educated and a believer, could look at nature and come to the sort of conclusions that most of the others would come to. But he wasn't a great scientist. That's my point. That this attitude was not limited to science, but it is particularly focused on science. So I think the answer to your question simply is, yes, in part, but I don't think it's a full explanation. What was part two?
Well, part two, you have partially answered it, but let me just state is that in the 20th century, if you take the statistics of people, eminent scientists, particularly take a list of Nobel laureates in physics, it's a side interest, so I do that, is that there is a very minuscule amount of people who are Christians amongst them. Most of them are Jewish and Jewish atheists, of course. So does it have any bearing, like, because this is a history, you're doing history of science, and history hasn't ended, it's still continuing. So have things changed, or it's still the same?
Yeah, well, I'm reluctant to talk about about living scientists, partly because some of them are my friends, but because I don't think it's ethically right to do that. But unless they say so. But I think it is certainly possible to do a prosopographic study. You know what that is? That's a study where you actually, it's quantitative history by numbers, as its opponents ridicule it, in which you analyse a society and work out which of the members is a Tory, which of the members is a Baptist, which of the members is got blue eyes or whatever, and you come to, I don't know what conclusions from it. Now, prosopographic studies have been done. I've done some myself, but not in connection with religion. And they can come up with some interesting answers, but they involve a huge amount of research. They're extremely expensive. And I don't think any has been done on the current society. The Faraday Institute may well get around to that. Will they?
They may.
You were going to... Did you put your hand up? Sorry.
Yes.
Oh, I had a question. Yes, I did indeed. No, I just, you said something passing and I may have misunderstood it, but I think you said that the Galilean's daughter was a mythology. And
No,
I think I misunderstood that.
No, I didn't say that.
No, I thought what
I
you
said,
did. And
I said there's mythology in it.
Okay, yes.
It's a work of fiction.
Could you amplify then on that statement? I would be interested to hear more.
Well, it's a long time since I've read it. 4 or 5 years.
Could you repeat my question to the camera? Sorry. Repeat question to the camera.
Well, I'll repeat the question, but I'm not going to give an answer because I can't.
Oh,
That's how I won't look at the camera.
Okay. Okay.
I'm going back to the question about Nobel laureates. I mean, were you happy with that answer? Do you want to press that a
We
bit?
can talk later.
Yeah. Okay. More questions? Yeah.
I was wondering, what is the premise that the notion the earth is the center of the universe, or earth is the center of the universe, or we are here and we are the main thing in the world? That kind of concept emerged in the biblical text or in the church. The reason I am saying that astronomy was subject of studies in the non-Western world.
Surely.
I am not familiar with that concept in Hindu astronomy or Islamic astronomy. What was the premise that it emerged in the West, that the earth is the center of the universe, or we are here? When God created man after his own image, kind of that transformed into the notion. What could be the reason? Because that is there lies the problem, that center periphery. What is the kind of hierarchy or prioritization? That the center is the main and the periphery is not so main. But if we take in holistically, then it doesn't matter, because we are part of the whole. And I was kind of interested in that part of the...
That's a very long question. I think what it comes to is, forgive me if I've got it wrong, what is the real basis for the widespread view that the Earth is at the centre of the universe? And I would say
I'm sorry, did Jesus Christ say in any of the sermons or the messages or
No.
anyone?
No.
Then is it any of his disciples say that?
No, certainly not.
Then is it the kind of organized church started saying that, or the social idea got into the mindset?
Oh no, the reason why Jesus didn't say it, or the disciples, they had far more important things to talk about and to do. But the Old Testament does have a lot of language about the universe, the language about the world, which is in a terrocentric, earth-centric framework. It does speak about the sun rising in the heavens and going like a bridegroom through the sky. It does speak about the earth not being moved. I've said the sun stands still story. There are many other things like it, where the Old Testament, well, very naturally, it speaks in the language of the people. That's the way that people think. That's the way you think, the way I think. So it's most natural. And it doesn't mean that it's been given special authority, because again, if Galileo is right, and if Viticus is right, the Holy Spirit has more important things to do than tell us features of cosmology, how to go to heaven, rather than how the heavens go. Does that answer your question?
Partly. If you see that the pursuit of the truth is the goal of science as well as religion, there shouldn't be any conflict or any problem for the church to pursue the truth, or to verify, or to go for it, rather than kind of feeling threatened by any new, scientific inquiry. I am interested that what was the reason that church couldn't accept any new idea or scientific inquiry, rather feel threatened and not embracing the inquiry. What was the reason? Political power, or
what was the reason for the persecution.
Exactly.
Oh, the reason for the persecution of Galileo is clear. I mean, Galileo was a guy who had been extremely tactless. As I say, he lampooned the Pope. He had undermined the authority of the head of a church which was then under increasing pressure from the rising Reformation. It really was in big trouble. That's why it tended to collapse itself into a coherent whole with the Inquisition, into a coherent whole with the Inquisition as its main weapon. Galileo also had the misfortune to come into a situation where the very inner councils of the church themselves were divided. And there was a personality fight going on between individuals. And this has been all written up. There's a huge amount of stuff on this. And Galileo's persecution was without doubt political in that sense, ecclesiastical political. And people, you see today, I mean, Dawkins would say, oh, it just shows how religion treats science, which has absolutely nothing to do with the real issue. And it was essentially a political thing. Indefensible, I would say, but that's a personal value judgment.
Perhaps to add to that, I think appeals to Augustine by on scientific grounds in terms of allegory and all
Right.
those sorts of issues
Yes.
could also be controversial insofar as Augustine was being appealed to by the reformers as well.
Oh, sure.
And so on, particularly going back to that kind of authority. More questions? Yes.
Yeah, I liked your comment about the eccentricity of the 20th century in returning to a literalistic view of scripture. And
19th, actually.
sorry,
Late 19th.
late 19th, but certainly 20th as well. And I wonder whether you have a view as to why this should be so. Why has a sizable group of intelligent Christians rejected their own Protestant tradition, rejected scientific insights to follow this path? Are we talking about social, cultural features of the last 2 centuries, or what
I
is it?
wish I knew the answer. If I knew the answer, it would be a terrific contribution, but I don't. I think, again, it's complex. It is at least partly to be associated with the American psyche, because it does come from America. The Scopes trial, for example, was in the 1920s, and a lot of the early opposition came from there. I think it springs from a whole cultural view of, shall I say, the oppressed classes. It comes from a very right-wing element, however, in the American church, politically right-wing. And I mean, the Bush administration would presumably be quite sympathetic to it. And certainly it's tied up with politics in a way that is so complicated. I think we need a special study of it. But there's no doubt in my mind, at least with this, that I mean, don't speak about the Bush. The creationists, that's what we're talking about. The creationist lobby has a strong political interest to serve. Of that there is no doubt. But beyond that, I wouldn't be able to go. I mean, I do know people who are deeply committed to Christians, who are very intelligent, who nevertheless take this view. I cannot understand it. I had a research student who was brilliant, American. He was a theologian, in fact, and he worked on a thesis which was very good. And he went over to America, back to America, and I had a letter from him saying, I know you won't be pleased to hear this, but I have joined an organisation which is going to promote this intelligent design thing. And he sent me a couple of books, one he'd written, one that somebody else had written, huge great things, which were intelligently constructed books. They were well written. I haven't read them properly, I haven't had time. But I mean, this guy was not a fool. He was a very bright guy. He was a very devoted Christian. Nevertheless, I think he's made huge mistakes, which I fear he will regret. So it's complicated. which is, I'm afraid is no answer.
Thank you. Any more questions?
Can we just come back to Galileo for a moment, Colin? You haven't sort of mentioned very much about the way in which the medieval church had absorbed Aristotle, and in a sense this was a conflict with deeply embedded Aristotelian views of the universe. Do you want to, is that the case, or do you not believe that, and therefore you didn't bring it up? I would be interested
I
to know
didn't
more
bring it
about
up because I didn't have a couple of hours to spare.
Oh, you've got some more
This
minutes.
is a question
Anyone
about
say-
Aristotle, the medieval church.
It goes back partly to an earlier question as to where this conflict was coming from. And I thought part of the conflict was this conflict with Aristotelian cosmology, which the church had taken on board as part of its system almost as a doctrine of faith.
Well, you must make a distinction, Dennis, between Aristotle and Ptolemy. Vital distinction. Now, the ancient Greeks came to their views because of the influence, largely, of Plato and Aristotle. I'm talking about first century people. And that, of course, entered eventually the stream of the Christian church. Now, if I can go back, I probably can't. Just like to show you something. No, it's one of those. Right, I just want to.
It's gone off the. You've got to get back on.
That's it, that's what I wanted. Now that is a picture of the universe that Aristotle produced. Aristotle, the guy who thought 4 elements for chemistry, didn't he do some damage there? But also who thought of the Earth at the centre of concentric spheres with the sun moving, as I say, along the equilibrium. That is the Aristotelian universe. It's not the Ptolemaic universe. That is quite different. That will not explain anything quantitatively. It merely gives a vague picture of the Earth and the sun in relative motion. And its emphasis is upon circularity. In fact, this circularity was part of the Greek inheritance which Copernicus could not extricate himself from. If he could only have gone to ellipses as Kepler did, he would have really got places. But he didn't, because, as Butterfield said, he seems to be a man who has caught his foot up in circularity, which is tripping him up. Now that is the Aristotelian view, which explains nothing quantitatively, but gives a pleasant general picture. Ptolemy, however, so this will not do. I've got to look at this in terms of the way the planets actually move. And the observations they had were incredible, absolutely amazing, considering they had no telescopes. And their eyesight must be brilliant. Anyway, it was Ptolemy who came up with the alternative view. Now, coming back to your point, Davis, Aristotelianism really had nothing to do with the Ptolemaic universe. Aristotelianism, which the church certainly had embraced and had lovingly committed itself to, simply thought the earth is at the centre and everything else goes around it, and it taught much more, which the church unquestionably, at least I've quite accepted. But my point is that it has really nothing to do with the Copernican revolution, because the Copernican revolution was not against Aristotle, but against Ptolemy.
But when Galileo came into the conflict with the church, wasn't that part of that story? That's part
Yes, they
100
brought
years
it.
later. So
That was later.
yes,
It was much later.
yes.
And Aristotle was just a main country that he was brought in, yeah. But the Copernican revolution was not a revolution against Aristotle, not primarily, but primarily against Ptolemy.
Isn't that a bit strong? I mean, Aristotelian view was certainly a geocentric view of the universe.
Sure.
Ironically, of course, the Earth is at the sink of the universe rather than the the pinnacle. I mean, gross matter sank to the earth, and,
Right.
and so on and so on. But I mean, certainly the Aristotelian general view, or indeed even I suppose say worldview, was geocentric in that sense.
Oh yeah, like that.
Yeah, right, exactly. So, and I mean, Galileo was such an abrasive character, really, wasn't he? And there obviously was a lot of academic politics between him and the Jesuits, with Aristotelianism being one of these.
I think it was probably more important in the Galileo case
Yeah, no, absolutely, yeah.
than in the Copernican case.
Yeah,
Because
no,
Copernicus, I mean, if you read, I've read De Revolutionis, 6 enormous books, and it's full of mathematics. I can't understand all the maths, I freely admit. It's full of mathematics, and it's all about the technicalities of which planet is where at which particular time. Whereas Galileo saw the bigger picture, and things have moved on too, and Aristotelianism has been reinforced by the church at that time. That sort of
Well, another interesting thing is this question of, that I'll say about probably about simplicity. And one of the reasons I think that everybody stuck with the circle was the circle seemed the most beautiful, the most simple thing to
Oh, yes.
about. And it was just a different form of beauty, which wasn't discovered until Newton got onto it, really. So
Yeah, well,
it's a sort of awful warning in a sense.
yeah, the circles were, of course, promoted. Plato thought that the circle was the most perfect movement, the most perfect figure, and therefore everything moved in the circle. And if it just didn't, you had to have another circle on top to go around and get it right somehow. But it was a fudge. I mean, this is one of the reasons why Copernicus did rebel, in that the equant was a fudge, in that it was not uniform circular motion around the Earth. It was uniform circular motion about an imaginary point in space, way away from the Earth. And that's one reason why Copernicus rebelled. It's often said that he also rebelled because his system was simpler, but actually it wasn't. He still used epicycles, and his system was virtually as complicated as Ptolemy's. So that, even that won't give us the answer. It's a bit simpler, but not seriously.
Yes.
A very simple question. I've heard it said that when Galileo published his book concerning two world systems, the Pope of the time, whose name I can't remember, initially endorsed it, having accepted the arguments. And then it wasn't until one of his functionaries pointed out that Simplicio was lambasting him that he then took against it. Is that correct?
I think that's true. Yes. His great enemy was a man called Cardinal Bellarmine, who was involved with intrigues in the Vatican at the highest level. He was involved in that particular.
Any more questions? I think there's an interesting parallel with evolution, and from going back to what you said about Bessel, in a way, that the real evidence for this Copernican theory didn't come until observation of stellar parallax. Well, in the case of evolution, there's still room for a lot of debate, I think, was going on at the beginning, when there were problems with the age of the Earth, and now, of course, we've got the modern synthesis of genes and so on. So,
Thank you, Roger. That was the point I was going to make and I forgot. Absolutely true. This business about evolution, the row about evolution with the church, then, in the 19th century, in the 20th century and today, would never, in my opinion, have happened if the church had understood the situation of Copernicus and Galileo. The issues are exactly the same. And that's one reason why I did Copernicus, because we're agreed on this, we can see. Now, if only you can apply the same criteria of the housework of Scripture to contribute to the problems of evolution, then the problems vanish into thin air. Almost, not quite, but almost. And this is why I think it does have lessons for today, very real sense. And I hope what I've said helps you to see that.
But I think some of the opponents of intelligent design today, they do not appeal to the Scripture. There are challenges to evolution is based on their challenge to methodological naturalism and some philosophy of science.
Oh yeah, well as I said last night, the real challenge to evolution weren't actually theological, they were social. In fact, evolution was going to take away, or could, the stability, the meta-stability, really, of Victorian society, which was on the brink of revolution. And it would rationalise and justify that, on one hand, and it undermined man's feeling of being superior to everybody else. And those were the real reasons why popular opposition to Darwin got so great. Not scriptural at all.
But there's a group of philosophers in the United States.
Oh yes.
Their challenge to evolutions and their defense of intelligent design was not based on the Bible.
Oh, yeah.
It's based on some philosophical principles.
Yeah, I mean, if ever you want to read a good philosophical send-up of evolution, read Mary Midgley. She has written some, I can't remember the title of her books, but there's one which actually exposes all the claptrap of evolutionary philosophy. I mean, I don't think she...
Science of Salvation, was that?
No, it's not that one, it's the other one.
Evolution is religion.
Ah, yes.
That's it.
Yeah.
That's it, yes. I mean, she writes not from a polemical point of view, but she's a philosopher. It's a breath of fresh air, I think. So I do recommend Mary's writing.
Sorry, what was that name again?
Mary Midgley.
Mary Midgley,
Yeah.
M-I-D-G-E-L-Y,
Right.
I think. Maybe I've got the E in the wrong place. Anyway, sorry about that.
Well, any more questions? Yeah.
Just one question which did not have complete bearings on the title of the talk, but more on history of science. You see, science consists of two parts. One is the theory and experiment. And in the ancient world, of course, it was more theory dating back to Pythagoras, not of course Archimedes. But for the advancement of technology, they should go hand in hand together. Now, in certain cultures, doing experiment, I know from the Indian society, because it's a Brahminical society, so everything is of the mind, which appeals to the man. And doing experiments is like a menial task which they don't want to dirty their hands.
Exactly.
But like coming from the Bible, it doesn't say so. Like each task is. So can you throw some light on that? So
Oh, yeah, I'd love to. This is a bit about experiments and getting your hands dirty. Certainly, the Greeks thought experiments were a bit off. You know the famous story of the Greeks who argued about how many teeth a horse had. And there was a great philosophical debate that went on several days. And then one of them said, well, there's one in the field next door. Why don't you have a look? And I think he was hung for heresy. You work it all out from first principles, and what are the mind? And this is Platonism, caricatured admittedly, this is Platonism, which infected medieval thought, so that doing experiments really was dirty work. And the only experiments worth talking about that were done in the Middle Ages were done by metallurgists and alchemists, and they were the scum of society, still are sometimes, and they were not regarded as being at all good role models. And then Francis Bacon came. And Francis Bacon, who was the Lord High Chancellor of England, and who wrote the many famous books, including the Organon, and he wrote, who was the inspiration for the scientific academies, Royal Society, and so on. And Francis Bacon wrote many wise things, but he said, we have got to get out of the habit of reading books, and we've got to get our hands dirty. Now that's not in the exact quote, I've got it here, but I can't give it to you exactly, but it was about that effectively. And it was Bacon who said, no, there's nothing wrong with technology, nothing wrong with doing experiments. In fact, he said, you've got to do it. He even argued the Bible favoured men and women working hard with their hands, which it does. So again, this is, where biblical doctrine surfaced, it actually favoured rather than hampered scientific investigation and experiment and the rise of technology, about which we're not saying anything this week, but that's another thing.
Bob, maybe just one quick one. Yes.
It's not a question, just a comment. The Royal Society, which sort of marks the take-off of science as a professional activity in the Western world, has as its motto nullius in verba, which broadly speaking means take no one's word for it.
Yeah. Thank you, Bob.